Well, our Cartesian coordinate system is what we're going to review today. So, without geometry, algebra would be pointless. That's what makes algebra unique, is the graphing aspect of looking at relations. So, keep your pause button handy. We're going to use it. I'm going fast on this one. Quick review on the Cartesian coordinate system. First thing we always want to label is our origin. Our origin is the root of our coordinate system. It tells us exactly where our axes are crossed. There's our origin. Okay? And then we need to label our axes. The x-axis is always the horizontal axis. The y-axis is always the vertical axis. Okay? To review our the way the quadrants are labeled, that is in a C pattern. So we always start in the far right. Let me erase that. You might want to keep yours on there, but I'm going to erase mine so it's not too cluttered. So now the first quadrant is right here. It is to the right, which is positive on our number line, and up, which is positive on our number line. The second quadrant, we use Roman numerals, is to the left. That's negative and up positive. The third quadrant is to the left, negative, and down, which is negative. These are our coordinates signs. Then our fourth quadrant is to the right, which is positive, and down, which is negative. That sums up the Cartesian coordinate system that we use to graph relationships between quantities. Now, the coordinate or ordered pair, that is written, ordered pair is another name for coordinate, x, comma, y, or x, comma, f of x. Okay, the higher you go in math, it's called the function, or denotes another letter, your input and your input in the function. We use it in the calculator as y because the calculator only recognizes y. So this makes a unique system for a picture of a relation. So relations can be graphed as a point or a set of points. These relations have certain domains, which is all the x values, and domains can be discrete. Discrete means it cannot be connected. There's not everything in between the points that you can find a value for. So let's think of that as if we were to find a value of something that is in between 1 penny and 2 pennies. There's no such value between 1 penny and 2 pennies, so pennies are discrete. We don't have 1.5 pennies. So that's an example of something that's discrete. Continuous describes a domain that we can connect. If it has infinite number of points and it can make a line between points, then it's continuous. And I have a way of saying that so you always remember. So you'll get to hear that a lot. So we've got our domain. It can be discrete or continuous. And we have the range, which is all the y values. This sums up our Cartesian coordinate system.